Hi guys, in today's video we're talking about trigonometry and we want to show that this whole fraction is literally equal to tan theta given that the denominator is different from 0, right? So we're gonna start from the left hand side, which is this fraction, and our goal is to get tan theta. So let's copy here. So we're gonna start from this, right? And before we get started, let's remember some trig properties that can be useful, right? So the cosine of 2x, we know that is equal to cos square of x minus sine square of x, and the sine of 2x, this is equal to 2 sine of x cos of x, and also sine square of x plus cos square of x, this is equal to 1, right? So these are some properties that can be useful in this exercise, right? Now this fraction is equal to, as you can see here, we have cosine of 2 theta. We can write it down in this form. Same here, also here and here as well. So on the numerator we're gonna have 1 minus, and then cosine of 2 theta, this is gonna be cos square of theta minus sine square of theta, right? So we have cos square of theta minus sine square of theta, and then here sine of 2 theta is gonna be 2 sine of theta cos of theta, right? Then plus 2 sine of theta cosine of theta, right? And on the denominator we have 1 plus, and same thing, right? We can copy this, put it here, and then we have plus, same thing here, right? Now we can remove the brackets. So on the numerator we have 1 minus cos square of theta plus sine square of theta plus 2 sine of theta cos of theta, and on the denominator we have 1 plus cos square of theta minus sine square of theta, then plus 2 sine of theta cos of theta, right? As you can see, we have here 1 minus cos square of theta. This is basically going to be equal to sine square of theta, because if we bring this on the right hand side, this is going to be 1 minus cos square of theta, so it's going to give us sine square of theta, right? So this whole thing is equal to sine square of theta. We have 1 minus sine square of theta. This is going to be equal to cos square of theta, right? So this is equal to, on the numerator we have sine square of theta, which is this, and then we have sine square of theta again, right? So plus sine square of theta plus 2 sine of theta cosine of theta. Then on the denominator we have cos square of theta, which is 1 minus sine square of theta, and then we have cos square of theta again, so plus cos square of theta plus 2 sine of theta cosine of theta, right? Now we have sine square of theta, which is basically 2 sine square of theta, and same thing here. So let's write it down. So we have 2 sine square of theta, and we have plus 2 sine of theta cosine of theta, and on the numerator we have 2 cosine square of theta plus 2 sine of theta cosine of theta, right? Now we have a factor 2 sine theta here, a factor 2 sine theta here, so we can factorize, and same thing here, we have a factor 2 cosine and a factor 2 cosine here, so we can factorize, right? So this is gonna be equal to 2 sine of theta, and then we're gonna be left with sine of theta, then plus cosine of theta, right? And on the denominator, if we take 2 cosine of theta out of the bracket, so we have cosine of theta, then plus sine of theta, right? Now we can see that this is the same here, and we have a factor 2 as well, so this is gonna cancel out with this one, right? And we cancel 2 as well, so this is basically equal to, on the numerator, sine of theta, and on the denominator we have cosine of theta, right? And sine of theta over cosine of theta, this is basically equal to the tangent of theta. So we have got the tan theta. That was our goal, which is the right hand side here.